right? Large language models, LLMs, they really are everywhere these days, huh?
Yeah, they are.
It seems like every day there's a new one popping up, doing all sorts of crazy stuff, like
What?
writing poems,
Oh, yeah.
generating code, translating languages. It's wild. Like we've literally stepped into a sci-fi novel.
It really does feel like that sometimes, doesn't it?
It does, but here's the catch.
What's that?
Running these massive models, all these LLMs,
Yeah.
they take a ton of computing power. It's a resource hog, right?
Oh, absolutely.
Especially if you're not Google or Meta with their giant server farms.
Right, right. And that's exactly where this whole thing of activation approximation comes in.
Oh, okay.
Yeah, it's a technique that developers are using
Okay.
essentially to make these really, really power-hungry LLMs run faster and more efficiently.
So they're more accessible.
Yeah, especially on devices with limited resources.
That makes sense.
Yeah.
So let me see if I get this straight.
Yeah,
Activation approximation is like we're streamlining these complex models.
exactly.
Okay, got it.
Yeah.
But the research paper we're diving into today,
Okay.
it's called Activation Approximations Can Incur Safety Vulnerabilities, Even in Align LLMs.
hmm
And then it has like a subtitle, Comprehensive Analysis and Defense.
That's the one.
That paper suggests that this whole speed boost, it might actually come at a hidden cost.
Oh,
And that cost is safety.
you got it. That's exactly it.
Okay, so tell me more than that.
Yeah, so this paper, what they did is they analyzed like all these popular activation approximation techniques.
Okay.
And they tested how these techniques actually impact what we call safety-aligned LLMs.
What does that mean, safety aligned?
Yeah, so these are like, think of them as the good guys of the LLMs, right?
Okay.
So these are the models that have been carefully trained to like not do bad stuff.
Okay, so they avoid like generating harmful or inappropriate content.
Exactly, you got it.
Okay.
And for their experiments, they took like 10 different safety-aligned LLMs.
Wow.
From some pretty big names too, Meta, Google, Alibaba, the whole gang.
Oh, wow.
And they applied, these approximation techniques.
Okay.
And guess what they found?
What?
Even these carefully aligned models,
Mm-hmm.
they actually become more vulnerable to like different kinds of attacks.
Wait, so even the LLMs that are supposed to be safe, like the ones that are built to be ethical,
Right.
they can be tricked into like going rogue if we try to make them run faster.
That's basically the gist of it, yeah.
Wow, so what kind of attacks are we talking about here? Like what can happen?
So one of the major concerns is this thing called jailbreaking,
Jailbreaking. Okay.
where like basically a user can manipulate the model
Okay.
to produce harmful outputs, right?
Outputs that it wouldn't normally generate.
Exactly, exactly.
Okay, so it's like finding like a backdoor into the system.
Yeah, you could think of it that way.
Got it.
Yeah, think of it like this. These large language models, they have like tons and tons of parameters.
Okay.
And all these parameters, they interact in all these like super complex ways.
Okay.
Right? So what activation approximation does is it kind of simplifies those interactions.
Okay.
But the catch is sometimes those simplifications, they create unexpected vulnerabilities.
That makes sense. Like you're simplifying things to make it faster,
Right.
but you're also like potentially opening up these holes that weren't there before.
Exactly. Yeah.
Got it. So it sounds like it's not just about making things faster.
Right.
It's about where in the model those simplifications happen.
Yeah, you're getting it.
Because I remember the paper, it highlights the first few layers of an LLM as being particularly sensitive.
The first few, yeah.
What makes those early layers so crucial? Like, why are they so important?
So imagine you're building a house, right?
Okay.
You got to start with a strong foundation.
Yeah.
It's the same with LLMs.
Okay.
Those first few layers, they're like the foundation.
Okay.
They're responsible for processing that initial input, like whatever the user types in.
Okay.
And then they kind of shape how the model understands the task.
Okay.
So if you mess with those early layers, you're basically messing with the foundation.
Got it.
And that can make the whole model susceptible to like malicious manipulation.
And the researchers, they actually visualized this whole thing using something called MDS projection, right?
Oh yeah, they did.
I gotta admit, when I first saw like figure 5 in the paper,
Yeah.
my mind was kind of blown.
It's pretty cool, right?
It's like they took this incredibly complex, high-dimensional data
Mm-hmm.
that's representing like all the inner workings of the LLM,
Yeah,
and they somehow made it into something we can almost like see.
it's wild.
It really is.
Yeah, and what's super fascinating about that figure 5, it shows how activation approximation actually changes what's called the activation space of the LLM.
An activation space. Okay.
Yeah, basically it's like a map, but a super multi-dimensional map
Okay.
of how the model represents information internally.
Oh, I see.
And what they found is that the approximation methods they tested, it's like they were scrambling this map.
Okay.
And that scrambling, it makes it way easier for these malicious prompts to slip through undetected.
Oh, okay, that makes sense. So, like, they're disguised, and the model doesn't even realize they're bad.
Exactly. They're like wearing a disguise, blending right in.
Got it. So we've established that even these safety-aligned LLMs,
Yeah,
they can be compromised if we're not super careful about how we speed them up.
right. It's a delicate balance.
It is, it
Yeah.
is. But the researchers, they didn't just leave us hanging with a problem, right?
No, they didn't.
They proposed a potential solution called QuadA.
QuadA, yeah.
Can you walk us through that? Like, what is QuadA and how does it work?
Absolutely. So QuadA, it's all about like reinforcing those vulnerable early layers.
Okay, those first few layers we talked about.
Exactly, right, during the safety alignment process.
Okay,
So the basic idea is we want to make those harmful activations stand out more clearly,
okay.
even with the simplifications, like all the stuff that comes with the approximation.
Got it.
Imagine it like this, right? QuadA, it's like giving the model like a stronger immune system.
Oh,
It's making it harder for those malicious prompts to like disguise themselves and cause harm.
so QuadA is like a targeted defense mechanism,
Yeah, you could say that.
specifically for those critical early layers, making
Mhm.
them more resistant to these approximation tricks.
Exactly.
That's pretty clever. But I'm curious, like, is this just an academic exercise?
I see what you mean.
Or are there real-world implications for, like, those of us who are using LLMs every day?
Oh, it's definitely not just theoretical.
Okay.
This research has huge implications
Right.
for both like the developers who are building LLMs
Yeah.
and also anyone who's actually using them out in the real world.
Yeah, because these models are popping up everywhere.
They are.
Like, we've got chatbots.
Yeah,
We've got content creation tools. I mean, even medical diagnosis.
it's amazing and a little scary all at the same time.
It is a little bit, yeah.
Yeah.
So what you're saying is if we're not careful, this push for faster, more efficient models, it could backfire
It could.
and inadvertently lead to a decrease in safety across the board.
It's the risk.
Wow, that's a sobering thought.
It is.
So it sounds like we need to be really cautious
We do.
about just blindly prioritizing speed over safety when it comes to these LLMs.
Absolutely.
Like, we need to consider the potential risks before we just crank up the speed dial.
100%.
So we're talking about a delicate balancing act here.
Yeah.
And this research is like, it's a wake-up call.
Yeah, I think so too.
It's telling us that we need to understand these trade-offs
Right.
and make informed decisions about how we develop and deploy these powerful technologies.
I couldn't have said it better myself.
Because if we don't, well, who knows what could happen.
Exactly. And it's not just like the developers, you know?
Right.
Like we as users, we need to be more discerning too
Yeah, totally.
about like which LLMs we're interacting with
Okay.
and like really understand that there's no such thing as like a perfectly safe system.
Yeah, there's always going to be some risk, right?
Exactly, especially with this cutting edge tech.
It's like we're venturing into uncharted territory.
We are, yeah.
With these LLMs, and we're still trying to figure out all the, like, potential risks,
Yeah, it's
some of the
total.
challenges, and how to navigate it all.
Mm-hmm.
So this research is a good reminder, like, we need to be cautious
Absolutely.
and informed
Before
or
it
just
hurts.
jump in head first.
Yeah, for sure. I think one of the things that makes this paper so compelling is that
Yeah.
it goes beyond just saying, hey, there's a problem.
Okay.
It actually digs into the like technical nitty-gritty
Okay.
of all these different activation approximation techniques
Oh, interesting.
and how they impact the inner workings of these LLMs.
So it's not just theoretical, it's like practical advice too.
Exactly. Like, for example, they talk about this thing called the approximation interval.
Approximation interval.
Yeah, kind of mouthful.
It is.
Yeah, but essentially it's this range
Okay.
where the model's perplexity score, you know that thing?
Perplexity score. Refresh my memory.
Oh, yeah, sure. So perplexity, it's like how well a language model predicts a sequence of words.
Okay.
And basically, lower perplexity, usually that means a better model.
Got it.
So within this approximation interval, the perplexity, it doesn't really increase much.
So you're saying you get the efficiency gains without sacrificing accuracy.
Exactly, you're getting it. But here's the thing, right?
Okay.
There's always a catch.
There always is.
They found that even within this like safe zone, this interval,
Okay.
the model can still be tricked.
Oh, no.
Yeah, into producing those harmful outputs.
So even when it seems like everything's fine on the surface,
Right.
there can still be these hidden vulnerabilities.
Like a sneaky loophole.
It is. It's like a trap door.
Exactly.
Wow. So it really emphasizes the point that even like seemingly small tweaks to these models can have like huge consequences.
Absolutely, yeah.
The paper also mentioned a bunch of different types of activation approximation methods.
They did.
Can you give us like a high-level overview of those? Like, what are the main categories?
Sure, yeah. So some of the like most common techniques include
Okay.
quantization.
Okay.
pruning,
Pruning, okay.
and knowledge distillation.
Oh, okay. Yeah, I've heard of some of those.
Yeah, and they all have like their pros and
Oh,
cons
okay.
in terms of like speed, accuracy,
Okay.
and, what kind of vulnerabilities they might introduce.
So it's not just a one-size-fits-all approach.
Not at all.
Developers are using all these different methods to, like, optimize these
Right,
LLMs.
they're getting creative.
And each method has its own unique set of, like, trade-offs.
Yeah, exactly. And like the key takeaway from all of this is
Yeah.
those optimizations, they can really impact safety in ways we might not expect.
That's kind of scary.
Yeah, it can be.
Because we might think we're making things better,
Right.
but actually we're introducing these new problems.
It's like a hidden cost.
Exactly. So that's why this research is so important,
It
is making us, like, think beyond just the surface level, like beyond just speed and accuracy,
Yeah,
and consider the broader implications of, like, our design choices.
exactly. 100%. Thinking about the big picture.
Thinking about the big picture.
Yeah.
Speaking of implications, the paper really zoomed in on the vulnerability of those first few layers in an LLM.
Oh, yeah, they did.
Like, why are those early layers so susceptible to all these approximation shenanigans?
All right, so think of it like this, okay?
Okay.
Those early layers, they're like the model's
Yeah.
initial filters.
Okay.
They shape how the model interprets all that incoming information
Okay.
and sets the stage for like everything else that happens after.
So if those filters are messed up,
Yeah.
the whole model's understanding gets thrown off.
Exactly, yeah. If those filters are like blurry
Uh-huh.
or distorted, the model might like misinterpret a harmful prompt as harmful as...
Oh, so it's like it doesn't even realize it's being fed bad information?
Yeah, or vice versa. Right. It might see a harmless prompt as dangerous.
And then overreact.
Exactly.
That's not good.
Not good at all. And that's where QuadA swoops in to save the day.
QuadA, okay.
Yeah, remember that?
Yeah.
It's designed to like strengthen those early layers during that whole alignment process.
Right.
So it makes them way more resistant to those distortions.
So it's like giving those early layer, like a booster shot
Yeah, you can think of it that way.
to make them more resilient.
Exactly. So earlier you mentioned that QuadA,
Yeah.
it makes harmful activations stand out more clearly.
They did, yeah.
Can you elaborate on that a bit more? Like how does it actually like work in practice?
Okay, so imagine QuadA is like a personal trainer for the model.
Okay, I like that analogy.
Right. It's helping the model develop like a sharper sense of what's good and what's bad.
I see where you're going with this.
During the alignment process where the model's learning to avoid all the bad stuff,
Mhm.
QuadA is like, hey, pay attention to these red flags.
Got it.
It amplifies those signals so the model really learns to recognize them.
So even with the approximations, the model still got its guard up.
Exactly. It's like, hey, I might be running faster, but I'm still watching out for danger.
It's like hyper-vigilant.
Hypervigilant, exactly. Okay, so QuadA sounds pretty promising.
It does, yeah.
But is it a foolproof solution? Like, are there any downsides or, like, challenges in actually implementing it?
Well, in a perfect world,
Right.
it would be. But the truth is,
Yeah.
no security measure is ever going to be like absolutely perfect.
Yeah. There's always going to be someone trying to find a way around it.
Right, it's like that constant back and forth,
Yeah.
between developers trying to build secure systems
Okay.
and then, other folks trying to exploit them.
It's like a cat and mouse game.
Exactly, a never-ending game of cat and mouse.
So we always got to stay one step ahead.
Always one step ahead.
And that's why this research is so valuable.
It is.
It's like it's an ongoing conversation.
Yes, yeah.
It's not a one-time thing. We got to keep learning and adapting.
Absolutely.
And refining our approaches as we go.
Yeah, it's a constant evolution
Yeah,
of understanding those vulnerabilities
okay.
and then developing new strategies to mitigate them.
This whole conversation about speed versus safety in LLMs,
Yeah.
it feels so incredibly relevant right now.
It does.
Especially with how quickly this technology is evolving.
Oh, fast.
It's mind-blowing and a little bit terrifying.
Yeah, I agree.
Like, it's being integrated into so many parts of our lives.
Everywhere you look.
It really does feel like we're at like a crossroads
Yeah.
with this whole LLM thing.
It does.
On one hand, we have this crazy potential
I know, right?
to like revolutionize everything.
So many fields.
But then on the other hand,
Oh, God.
there are some serious risks
Real risks.
that we can't just ignore.
Nope, we've got to face them head on.
And this isn't just a conversation for the developers, right?
No, not at all.
This is something everyone needs to be thinking about.
Yeah, for sure. I totally agree.
This isn't just a tech problem, it's a societal one too.
100%.
We need to be having like these open and honest conversations about like all the ethical implications of LLMs, the
Uh-huh.
potential trade-offs, and like what values we want to build into these systems.
Yeah, that's huge.
Because, like, it's easy to get caught up in all the technical stuff.
It is, yeah.
But ultimately, we're talking about tools that are going to shape, like, how we interact with the world.
Exactly.
How we communicate, how we access information.
How we learn.
How we make decisions.
All of it.
And those are, like, deeply human concerns.
Deeply human.
I'm really glad you brought up values, though, because, like, it's so easy to forget about that.
It is.
When we're talking about all the tech stuff.
Yeah, it's easy to get lost in the weeds.
But this research, it's a perfect example of how we can start having those conversations.
Yeah, exactly.
It's not about, like, being afraid of AI.
No, never at all.
Or trying to demonize it.
Nope.
It's about understanding how complex it really is and working together to make sure these technologies are used responsibly.
Responsibly and ethically.
Exactly.
That's the goal.
You know, this whole thing about the vulnerability of those first few layers.
Yeah, the foundation.
Really stuck with me.
Yeah, it's like if the foundation's weak,
yeah,
the whole thing can crumble.
It makes you wonder, like, what other hidden vulnerabilities are out there?
Right. Like, what else are we missing?
Things we haven't even discovered yet.
Yeah, it's a little scary to think about.
It is a bit, yeah.
But it also highlights, like, how important ongoing research is.
Yeah.
We can't just assume a system's safe.
No.
Just because it passes some initial tests.
Right. Like, it could be a false sense of security.
Exactly.
We got to constantly be probing for weaknesses and developing new safeguards.
It's like a continuous process.
It is.
Of learning and adapting.
And refining our approaches.
Kind of like they were always learning new stuff about the human brain.
Totally. Like, our understanding's always evolving.
Yeah, exactly.
This is what makes this whole field so exciting, though.
It is exciting.
Like, we're constantly pushing the boundaries.
Pushing the limits.
Of what we know.
And what's possible.
This deep dive has given me so much to think about.
Me too.
Before we wrap up.
Yeah.
Is there anything else you want to emphasize for our listeners?
Let me think.
Like, any key takeaways you want them to remember?
I think the biggest one is, like,
yeah,
we can't be passive with this stuff.
Right.
Like, we can't just sit back and let it happen. We got to be informed.
Okay.
We got to be engaged. And we got to be critical thinkers.
Critical thinkers, yeah.
Like, question the outputs of these models.
Okay.
Understand their limitations. And demand transparency.
Yes.
From the companies that are building them.
That's so important.
It is.
Because it's easy to get swept away by all the hype.
Oh, yeah, the hype is real.
But we got to approach this stuff with, like, a healthy dose of skepticism and critical thinking.
For sure.
As these models become more and more integrated into our lives, like shaping everything.
Everything.
What other hidden trade-offs should we be thinking about?
Wow, that's a big question.
It is a big question.
And there's no easy answers.
But the more we understand how these systems work, the better equipped we'll be.
Definitely.
To navigate all the challenges.
And the opportunity.
That they present.
For sure.
But this has been an amazing conversation.
Yeah.
I've learned so much.
Me too. It's been a pleasure.
For our listeners, if you want to dive deeper into the research we discussed today,
yeah, check it out.
You'll find links to the source material in the show notes.
And be sure to join us next time.
For another deep dive into the world of knowledge and ideas.